As with any good application, it should come with a nice suite of tests to verify behavior, as well as a way for you to add to that test suite. So when you add new features or find a bug, you can write a test that covers those use cases. Jumpstart Pro Android is no different. We have a test source set inside of our app, inside of SRC. This is where all of our tests are located. So let's go ahead and close all of our files out here and go inside a test, and we'll see Kotlin, and then we have a bunch of various tests that are in here. Now, I want you to note there are two different types of source sets for Android testing. There is the test. These are typically called unit tests, which is why we see unit test in brackets here. There is also another one that is not present here, and that is called Android test. Those are typically end-to-end UI tests, where the system is actually clicking on particular buttons to perform an action. We do not have any of these tests with Hotwire Android because Hotwire Android is powered by the server. Without the server, Hotwire Android will not work. So we would need a server implementation to execute that on. Now, while that is possible, we have not developed that internally. However, we do have the capabilities and functionality for you to test certain scenarios with it talking to a server, which we'll talk about shortly. So let's go ahead and hop into a couple of example tests just so you can see how they work. So here's a bunch of the tests. We have some coroutine stuff. This is all based around enabling us to test asynchronous communication. We use test dispatchers. Dispatchers are a way for us to say, hey, we want this to be on a main thread or an IO thread or a background thread. And test dispatchers give us a way to kind of make them all the same, so we don't run into some weird edge cases where we have a race condition, or maybe we need to advance the time because something needs to happen 10 seconds later. Test dispatchers allow us to manipulate all those things in tests. So that's what this is for. And the coroutine test rule allows us to kind of set that up very, very nicely. Inside of there, we have Jumpstart Notification Manager tests. We have HTTP. We have 2 API result tests. This is just a very simple test that showcases how we have an extension function. So we have this network response, and I want to turn it into an API result and verify that everything's correct. So all this class does is verify that all this code works. And so we're creating these network responses, and we're verifying that we're using all of them correctly. Now we see assert that this is an assertion library. This is not the JUnit assertion library that comes with traditional Java unit tests. This is the Google Truth assertion library. Allows for a little bit more of a fluid syntax, easier to read than a traditional JUnit syntax, in my opinion. We are using JUnit to run these tests, so you can see JUnit 4 here. Now there are other different types of tests. These are just very unit-based tests. We put something in, we get something out, and we test it. There's other different types of things where we might need to perform some mocking. So inside of the notification repository test, we have an API service. We need to mock it. So this is one reason why we use the interfaces, such as this an interface here. We might use an interface for something else. If we let's look at the user repository, is even better one. This has a notification repository. This uses an interface. It has a cookie manager delegate, so we don't actually talk to the real cookie manager, which is all static based. And API service, we can perform mocks, and this is using Mockito to provide these mocks. And so in this instance, we can set up our mocks to say, hey, anytime API service is called, sign out is called with any parameters, then return a network response that's a success with a response code of 200 and an empty body. And then same thing for the notification repository. When we ask for the push notification, then just return this notification, which is just a hard-coded string. And when the cookie manager get cookie is called, then return some cookie here. So we can force these different scenarios to happen. And then we can set up different shared preferences and so forth and execute. We can verify that certain things happened on these mocks, that, we did call sign out once with this notification, that we did call this push notification only once. Similarly, we can verify that certain things did happen. So if we get a HTTP 500 code, we want to verify that that server error is what we expect it to be. In the API exception message, we can verify that things have been called here. And also, furthermore, we can verify that certain things have not been called. And the good example of that is it's actually going to be in the Jumpstart Notification Manager test, where we verify something doesn't happen. And we can use a fluent syntax for the naming of the tests here, and they say when a user's logged in and the token already exists, and then Firebase nor the notification repository should be called. So we're verifying, if we look at the actual implementation code here, register for notifications, we're verifying that if the user's logged in and we have a notification token already, then we should return already. So we should exit out. We should get out of here by then, and Firebase shouldn't be called, and the notification repository should never be called. And that's what this is doing down here. verify that we called is logged in once, and then verify that we never call on new token, and verify we never call persist push notification with any strings whatsoever. So we can verify that our classes are integrating correctly together. So these are like integration based tests. These are all based again on JUnit. We can see these ones we're running with Android JUnit 4 because we do need some coroutine stuff. We do need various things like the application provider so we can get a shared preference object, which is something particular to Android, and Android JUnit 4 runner allows us to do that. There are also interesting tests here for the main activity. This is one where you can use as an example of how to work with something known as MockWebServer. MockWebServer is a web server that runs in memory during a test environment, and you can configure it to reply with certain messages. So when a request actually goes to the API, MockWebServer will interpret that and say, hey, here's what I want you to reply with. So you can actually test these interactions across the layers. And that's what we have set up here. We have MockWebServer. We're going to start the web server on port 8080. Now, the app needs to know about a base URL, because remember, we have the app URLs, which is what's used all over the application. App URLs. And app URLs uses this base URL. And if we look at the implementation of that, the base URL is provided into the implementation. This is provided by a base URL that's configured through dependency injection. Now, because we are using dependency injection, which is this one right here, we have told this test to go ahead and uninstall this dependency injection module because this is being used in Hilt. This is a Hilt Android test. As you can see, it's configured here. And we're going to say, hey, uninstall that module. So Hilt, Dagger, forget that you know about that thing. And then we're going to bind this up manually. And we're going to create this here and say, hey, we know for a fact we want this at localhost 8080. And then when the MockWebServer starts, it'll be at port 8080 on the localhost. And then when we're done, of course, we tear it down. So the cool thing here is what we can actually do is we can verify that bottom navigation has 3 tabs. Well, where do these tabs come from? If we remember to look at our configuration.json, we can see that we have the tabs up here. These are serialized as JSON, and they is actually an array of 3 values. And so we can test to verify we get these 3 tabs. However, we need to enqueue a notification. Which one do we want to enqueue? We're going to enqueue this notification, this configuration right here. So we say configuration.json. It's going to load this configuration right here. So we can create multiple other tests that has a footer. This one has a footer. If it doesn't have a footer, we can verify that it's there. We could then create another configuration and pass that in here and say configuration without tabs, and we would verify that we do not have any tabs. So we're using compose to actually verify we do have some tabs down inside of our compose view. It's very easy to just create another configuration.json, remove those tabs, and write another test that verifies that there are no tabs. But you can use this as an example if you need to communicate with the server for any reason in a real working environment. You can use MockWebServer, which is a hermetic environment. It'll run completely disconnected. You don't need any network activity as it's all stored in memory. And so all these tests can be run very easily. You can right click on one test in here and say run tests, such as we can do here. It'll run the main activity test. You can run all of the tests very simply by going to the test up here and then right clicking and saying test. Okay, so we can see that our test did run here, and we can actually say, we want to see all of the tests here. So we see the ones these are ones that have been successful. If we want to run all of our tests, we could right click here and hit run test. This is going to take some time because it's going to execute all of our tests, but we can see them already executing here. It's already run all these tests, and now all of our test runs have been completed. These will be run on every CI build. So if we look at the Android CI, we can see that we're going to run the test right here. GradleW app test. This will run after lint and detect a run. We'll run the app test to verify that all of our tests are still working. And that's how our tests are set up inside of Jumpstart Pro Android.